Welcome to the next video in the GaneshaDx tutorial series. This time we're going to talk about animated meshes. It's a little bit complicated, but hopefully we'll figure it out together. Let's go ahead and get started. I've opened the same scene that we've been working on in the last few tutorials, and this time we're going to add a spinning crystal over this tile here. First thing you want to do is go to the Map tab, go to Manage Map Resources, and you'll see that there's two fields here that we haven't looked at yet. Animated mesh frames and animated meshes. Each map can have a total of 8 animated meshes, and those are indicated by these 8 checkboxes here. We're going to go ahead and select 1 and 3, and under animated mesh frames we want to put a check mark. Animated mesh frames is the instruction set for all 8 animated meshes. Without animated mesh frames, your animated meshes will never do anything, and probably the game will crash when you load. So this is mandatory if you want to include animated meshes. I'm going to close this, and now if we go to our Polygon tab, we'll see that we now have a new section up here that allows us to select which mesh we're working on. If you click this drop down, you'll see that we now have animated mesh 1 and animated mesh 3. You remember, we selected 1 and 3 here. For this tutorial, we're only going to work with 1. And so I'm going to uncheck the third one, and when we go back to the Polygon tab, the third one has been removed from here. So this drop down will only allow you to select the animated meshes that you have chosen in your Manage Map Resources panel. So let's click on Animated Mesh 1, and the first thing that you'll notice is that we can no longer click on any of the polygons for our primary mesh. If we go back to primary mesh, we can now click on them again. So let's go to our animated mesh 1, and we're going to add a polygon. We're going to add a textured quad. Now we have one polygon here. We're going to position it at the 0, 0 axis and rotate it so that the red is in the top left over here. We're going to look at these position points to make sure that we're at 0, 0, 0. There we go. Now we can't see our polygon anymore. And that's because our primary mesh is hiding it. If we go to Animated Meshes and click Isolate Mesh, it will hide all other meshes, including other animated meshes that you have created. This is super helpful in actually modifying your polygons. Now you'll see I can't click this polygon. The reason for that is that our animation is technically playing right now. Even though nothing's happening, or there's no animation being played, it is in the play mode. The reason that no animation is being played is because we haven't set one up yet. Let's click this button here that says Edit and Mesh Animations, and there's options down here to stop and play the animation. First, we're just going to stop it, and you'll see now we can click our polygon. When we hit play, it no longer allows us to modify our selection set. All of this stuff we'll cover soon, but this is what controls and sets up our actual animation. First, we're going to create our animated mesh, though. Like I said, we're going to create a crystal, so I'll do that now. Okay, we've created our mesh. We also want to position our mesh so that one of the vertices of our mesh here is aligned with the 0, 0 position. And I'm going to align the very bottom vertex of the entire scene here. Okay, and the reason that we want this to be at 0, 0, 0 is because this is our reference point. All of our animations, which include our position, our rotation, and our scale, will be focused around that point. So if we were to scale up our animated mesh through animation, it would scale away from this point, so it would grow bigger, and this point would stay in the same spot. If we were to rotate it, it would rotate around this spot. So the entire crystal might rotate like this around this anchor. And then position, we'll position it using this as our base. If we were to move this animated mesh to say 10, 10, 10, when we do so, this vertex here will be at 10, 10, 10, and all of these will be positioned in relation to that. The polygons that make up our animated mesh have the same properties as the polygons that make up our primary mesh. That includes our normals, that includes our position, our terrain level, and invisibility angles. Terrain level, or terrain binding, will not be represented in this. If we set these to say 0, 0, 0, if our 0, 0 terrain tile is highlighted, it will not highlight any of these polygons. So, we've created our animated mesh, and now we're going to animate it. And we do so with this panel that we opened with this button that says Edit Mesh Animations. This is a very complicated menu, but after I explain it, hopefully it'll make more sense. The first section that we have here is our mesh and our state, and we can have up to 8 meshes. Like I said earlier, we can have up to 8 animated meshes in our scene. We're only using 1, so we'll only use mesh 1. And then each animated mesh has 8 states. Each state is a collection of animation instructions. You can have up to 8 per mesh, but we're only going to deal with the first one, state 0. In order to use states 1 through 7, you will have to use some scripting, which is outside of the scope of this. If you would like more information about scripting, the GaneshaDx Discord has a scripting channel, and you can do some really cool stuff with it. But for the sake of this tutorial, we're only going to focus on state 0. The next section that we want to look at is this here for our keyframe ID. If I were to change this to, say, just some random values, and click plus on our keyframe ID, you'll see that these values have changed, and when I click minus on this to go back to 1, we've got those properties. We have up to 128 keyframe IDs that we can use. And each keyframe ID has its own set of instructions for the position X, Y, and Z separately, the rotation X, Y, and Z, and the scale X, Y, and Z. The way that this works is that each animation state for your mesh has a list of instructions, and these instructions will tell which of these keyframe IDs to use, indicated in this left column, for how long to play that animation, and what our next frame ID is. This is a little bit complicated, but I think after we see an example, I think you'll understand it. Okay, so the first thing that we want to do then is on frame 1, these are each of the frames of our animation for our mesh, is we're going to use keyframe ID 1 for its information, and we're going to tell it to be a duration of 120 frames, which is 2 seconds. And when we're done, we're going to go to frame 2. Actually, we're going to go to frame 3. On frame 3, we're going to use keyframe 2, and this is going to be a duration of 15 frames, or a quarter of a second. And when this is done, we'll continue and loop back and play frame 3 again. So on keyframe 1, we want to position our crystal, and on keyframe 2, we want to have our crystal rotate and bob up and down. We will control keyframe ID 1 to put our position. Now we said that we want it here on this polygon. So let's switch back over to our primary mesh and look at the position of this. We see that our Y is 12 and we want it to hover above this, so we're going to set our Y to, say, 18. Let's open up a notepad and say, so we know we want our Y to be 18. We want it to float about 6 units above the ground here. We also want it to be centered on this polygon, so we'll take the minimum value and the maximum value and figure out the middle point of that, which is done pretty easily just by taking the large extreme, subtract the minus extreme, divide that by 2, and then add that back to the minimum extreme, which we have here is 140. So we take 140, we subtract 112, 28 is the width of our polygon. We'll divide that by 2, so that's half the width of our polygon, and we're going to add it to the minimum of this, which is 112. So we're taking the 112 position and adding half the width of this, so we get 126 for our x. And then for our z, we want to do the same thing. So 112 for our z, as we see here, minus 84, divided by 2, plus 84 is 98. Okay, so let's go back to our animation. Let's open up our notepad and leave it pinned up here. And we're going to say tween 2 on the x, 126. We're going to tween 2 on our y, 18. And we're going to tween 2 on our z by 98. We're also going to just set these to tween by, because we don't want to leave them as invalid. That will crash the game when we open it. And we're going to play our animation, and you might be surprised at what we see. Well, our crystal disappears. So why is that? This is a very big gotcha with animated meshes. The reason that this is happening is because our scale is set to 0. So we want to set our scale to 1. We'll talk about how each of these fields works in a moment. And now if we play, we will see our crystal appear over there. Perfect, right? The only thing is that instead of tween by, we want to say tween 2. And then it gets positioned there, and you can see it's hovering over the ground. And our anchor point that we talked about earlier is at that position that we calculated earlier. Okay, so now what do we do? If you click the little button right next to this, it will automatically select the keyframe for that entry. So if I say set this to 68 and hit this, our keyframe ID has updated to 68. And it's now orange because this is the keyframe that we have indicated over here. Let's change this back to 0 and choose this. Here we want to have it spin and rotate in place. So we want to say tween type, tween by, tween by, tween by. And we want to rotate around our y-axis by, say, 45 degrees. We'll cover what all of these do in a moment. I just want to show you this animation playing. And after a couple of seconds, it'll start spinning. Okay, so what did we do to make this work? Let's talk about what we did. The first property that we have is our tween type. We have tween 2 and tween by as our most commonly used ones. We also have oscillate and oscillate offset. What tween 2 does is it will take our current position and tween it to this value. So if we hit play, after a second it will move over to 0. Tween by says to tween by that amount. I know it's a little confusing to explain the difference, but tween 2 is sort of an absolute term. If you say tween to position 0, your animation will transition your position to 0, whereas tween by says change it by 0, basically meaning stay in the same spot. Okay, now when we played this first one and we have this tween 2 and on both our scale and our position, it's snapped over there, whereas on this one we actually see it playing that animation going from its current value to its destination value over the course of the duration. The reason for that is that the first frame in your animation will always snap to that position. If we were to play this, you'll see that it snaps directly to here, and we wait 2 seconds before it starts going to the next ID. Let's set something here. Let's make it a new third one, and on our third frame ID, we're going to set everything to tween 2, 0. And after we rotate, let's make this a little bit higher. After we rotate, we'll go over to frame 5, and then we'll go back to frame 1. Let's watch what happens. Let's move this out of the way so we can see it. We snap there. Now we'll rotate 45 degrees over 2 seconds. We forgot to give a duration, so this is happening instantaneously. We're moving straight to there. Let's change that. That was not intentional. We'll transition to that 000 point over 2 seconds. So it snaps. It'll rotate, and then over 2 seconds, our scale and our position go to 0. Now it plays this first frame again, but this time it doesn't snap to this position. It's because this is, even though the first frame, it's not the first time that frame has been played. Hopefully that makes sense. I know that this is a very complicated topic. Let's look at our next property. We have two properties here that say start percent and end percent. You want these to be 0 and 100 for each of these on all of our keyframes. Now it doesn't seem to make a difference here. However, it does make a difference in game. GaneshaDx is still an alpha program, and so there are some features in our mesh animations that do not quite work. All of the properties work. However, they don't all represent accurately in GaneshaDx as they would in game. We're still discovering a lot about how this animation system works, and so as you're playing around with it, you'll start to see some differences between what you see in Ganesha and in your actual running game. Anything that you find that you can find concrete information on, we'd love it if you could share it in the Discord, and we will make those modifications to GaneshaDx. We just haven't had time to investigate it and then implement most of that. But often, your start and end percentage will be the reason that your animations are not playing correctly. So we'll set all of these to 0 and 100 on every field that we have. Since we talked about it, let's actually discuss what it actually means. We can see that our crystal is going back and forth between here. If you imagine during this frame that this is at 0% and this is 100%, by saying our start percentage is at 0% and our end percentage is at 100%, our animation will go from the entirety from the very beginning to the very end. If we were to change our start percent to 50% on this, what would happen is that instead of starting here, it would move down here. Let's remove this. It would start down here. Our animation would play our crystal to move all the way down here. However, when it returns back to this spot, it will start at the 50% point. So it'll start from here, and then it'll snap to the 50% point, and then over the course of the 2 seconds transition from here to here. The same would happen if we flipped this. If our start percentage was 0% and our end percent was 100 or 50% to put there, our animation would start here, over the course of 2 seconds go here, and then it would snap to its final destination. You'll have to play around with this in-game to see exactly what I might mean by this, and strongly encourage experimentation with this. For your basic stuff, if you want to just animate things moving, scaling, and rotating, this will cover 90% of the cases. It's not going to be very common that you'll want to have your start and end percentage at anything other than 0 and 100%. You'll probably get pretty tricky with it, and that's advanced stuff. As you're getting into it, if you're doing just basic things, making a crystal rotate in place, making a bush move back and forth, or whatever, keep your percentages 0 and 100%. Let's also talk about what these positions actually are. So the values for our position are our actual unit positions, which we saw when we calculated out for this frame. This was the real in-game positions. Our rotation is a value between 0 and 360. It can also be negative, so you can see that our crystal rotates a little bit. Let's just have our crystal spinning in place here. So our crystal will spin this way indefinitely because we said that our next frame, I'm sorry, I meant to put 3 there. Our next frame will be 3, and it will just spin in place indefinitely. if we go here and we change this to, say, 360, see that we're spinning in a clockwise or in a counterclockwise motion. If we set this to negative 360, it now spins in a counterclockwise motion. That's how you control the direction of your rotations. Finally, our next property is scale. This is a value between 0 and 1. So if we were to change this so that our y will grow by just a little bit, see that every time that this animation plays, our y is being stretched up. Let's watch that happen. So we're tweening by 1.1 times scale. It's going up just a little bit slowly. Now, if we set it to 2, this will double the size of our crystal. We'll go ahead and do this to all 3 of them. Actually, 1 for tweening by. What will happen is every time that this animation completes, it will have grown by 1 times. You can see it's grown pretty fast there. There is a limit in game to how big things will look when they render. That's something you'll have to experiment with if you really want something to be that big. So that's all of our values and our start percentages. Now, Tween Type, we have 2 new properties here. We have Oscillate and Oscillate Offset. We're going to modify its up and down position. So we're going to oscillate its Y position by 3. Now you'll see that we're moving up and down. What's happening is that we start at position on Y at 18, and Oscillate says to oscillate by 3 units. So what will happen is that the bottom of this will go up by 3 from 16. Where did we start? 18? It will go up by 3, starting at 18, up by 3 goes up to 21, and then it'll go to 3 lower than our start position. So 18 minus 3 is 15. So what will happen during 2 seconds of animation is that it will go up to 21, down to 15, and return to 18. And it will do that in the course of this 2 seconds. And it will end up at the same point that it started at position 18 at the end of those 2 seconds. And so it will continue to do that. Oscillate Offset is a little bit weird. It is not represented in GaneshaDx yet, and we're not entirely sure how it works. It does some sort of snapping to a new position, like it starts at 18, snaps up to 21, and then goes down to 15, and then snaps back to 18, or something like that. We have not investigated exactly what Oscillate Offset does to an extreme degree, and again, if you can find any rules or logic on how that works, we would greatly appreciate any findings that you have. And so that's it for animated meshes. I know that it's a very complicated topic, and a lot of this tutorial was telling you basically experiment on your own and see what happens. And that's it for our GaneshaDx tutorial series. Now that you've made it through all 7 chapters of this, you will now know everything you need to know to start making your own maps, and I can't wait to see what you make. Thank you for going through this entire series with me.